So this video is about how to do basic stoichiometry problems. Stoichiometry is basically calculating how much product you can make from a specific amount of reactants. The limiting reactant is going to be the one that runs out first. It's going to limit the amount of product that can be produced. And then the excess reactant is going to be the reactant that doesn't get used up completely, that there's going to be more of at the end of the reaction. And the limiting reactant is going to be the one that determines how much product you make because it runs out first. And then your percent yield is your actual amount of product that you make versus how much you theoretically should have made when you calculate it. For example, if you were to spill something on the table and that mass wasn't weighed, then that would lower your percent yield because you should have produced more than you did. To calculate it, you just do how much you actually made in the reaction, divide that by how much you theoretically should have made in the reaction, and then multiply that by 100. And those are just the basic definitions you should know. So in all these problems, we're going to be using this reaction right here, N2 plus 3H2 yields 2NH3. And this question is how much NH3 can be produced from 10 grams of N2. We're given excess amount of H2, so you don't have to worry about that reactant right now. For problems like this, there's just three basic steps. You're going to divide by the molar mass, multiply by the mole ratio, and then multiply by the molar mass. So given in the problem is 10 grams of N2. Divide by the molar mass, which here is 28 grams per mole. And that's going to give you 0.3571 moles of N2 because you have grams divided by grams per mole. So that's going to cancel out to just make grams. For the mole ratio, you're going to look at what you're going to produce, which in this case is the NH3. That coefficient is a 2 that goes on top, and then N2 has a coefficient of 1. So your mole ratio is 2 to 1. So you multiply that together, you just get 0.7142 moles of NH3. Multiply by the molar mass of NH3, 17.03, and you get 12.16 grams of NH3 produced. For this next one now, we're going to have not an excess amount of H2. So we're going to have 10 grams of H2 and 40 grams of N2. And we need to determine the limiting reactant before we find out how many grams are produced. We can't compare these amounts directly because they have different units, grams of N2 versus grams of H2. So the only way to compare them is to get them to the same unit. To do that, we're going to divide both of them by their molar masses, 28 again, and for the H2 it's 2.02. We still have different units, moles of H2 versus moles of N2, but now we can multiply by the mole ratios, which again is the one you're going to, 2 over what you're at right now. So it's a 3 for the H2 and a 1 for the N2. When you do that, you convert it to moles of NH3. And now we can compare these because they have the same unit. And we know that this one, the N2, is going to be the limiting reactant because it produces less. So this is going to be the actual number of moles of NH3 that are made. Because before you can make the 3.3 moles, all your N2 is going to be used up. So we're going to have extra H2 left over. So at this point, you don't need to continue up here because we know that this is now irrelevant because we're not going to make that much. We're just going to make 2.857 moles. So multiply that by the molar mass, and we know we get 49.17 grams of NH3. Also with stoichiometry, you don't have to go directly from reactants to products. You can also go from one reactant to another. So, for example, if you wanted to find out how much N2 you needed to fully react with H2, then you could do stoichiometry that way. Start with the 20 grams of H2. It's basically the same thing as before. Just divide by the molar mass, so you get your moles of your first reactant. And now you're just going to multiply by the mole ratio, and this time you're just looking right here. So it's going to be a 1 to 3 ratio, it's coefficient of 1 over 3. So you're basically just dividing 9.09 by 3, and that gets you 3.03. Multiply by the molar mass of N2 now, because you're in moles of N2. And that's going to get you 92.4 grams of N2 are required to react with 20 grams of H2. You can also work backwards from how much product you have to how much reactants you would need to make that. So if you needed to make 15 grams of NH3 and you need to find out how much H2 you needed for that reaction, you can do stoichiometry this way. So start with your 15 grams of NH3 that you need. Divide by its molar mass. So you need 0.881 moles of NH3. Now you need to find how many moles of H2 you need by using the mole ratio, which is going to be 3 over 2. So you need 1.32 moles of H2, and then we want to convert that to grams. So we're going to multiply by its molar mass, and we need 2.67 grams of H2. So now we have this last problem, which is to find the percent yield. We have given from the problem that 12 grams of N2 are reacting. Same thing as we've been doing the past few problems, the same 3 steps. Always divide by the molar mass to get the moles of reactant, divide by the mole ratio, and that's going to get you moles of product. Multiply by the molar mass. So theoretically in this reaction we should have made 14.6 grams of NH3, and we actually made only 13.74. So you're going to take that 13.74, divide it by how much we should have made, actual divided by theoretical times 100. That's going to get us 94.11%. And basically just to recap everything we just did, if you have a question that says there's excess in the equation, all you have to do is those 3 steps, go from grams to moles, moles of one reactant to moles of another, and then go from moles to grams. Here you're just using the molar mass, the mole ratio, and then the molar mass of the product. To find the percent yield, you're going to find out how much should have been made and how much was actually made, and you do actual divided by theoretical times 100, that gives you a percent yield. And to find a limiting reactant, you can want to convert both things to the same unit, and whatever makes less is going to be your limiting reactant. It's going to run out sooner, and your other one is your excess reactant, and you're going to have some left over. And we're all set.